So hello everyone. Welcome back to our last day of Intro to R workshop. So in the previous 2 days, we have finished the R basics about the very basic building blocks, and also talk about the programming structures like the flow control loops, functions. And in yesterday's workshop, we also learned something about the file input output, and we almost finished this data wrangling part. There are actually 2 left sections we are going to talk about today, but basically we are there. And for today, we are going to do some data visualization in the R environment, specifically using the ggplot2 to make plots. And about ggplot2, I think it's important to learn the syntax, grammar, and the elements with ggplot2. So basically, ggplot2 is a very powerful data visualization tool. You can make you can use it to make the publication quality figures, which can be used for your paper or for your presentation, poster, etc. So we are also going to learn the basic plot types and something about the customization. And lastly, we are going to do some kind of practical practice with the R Studio. Try to cover those topics as well as some statistics. So this is our day 3. The main topic will be data visualization. And as usual, we are going to have a 10 to 15 minutes break every 45 minutes. And the topics here is we are going to finish the data wrangling, and we will move on to the R Studio to do some practice with the data wrangling. And then we will learn the visualization part. So before we move on, I still want to take maybe 5 minutes to go over what we have learned so far about the summaries, day 1 and day 2. So basically in the previous 2 days, we learned the basics about variables, like the variable names and how to assign the values. We also learned there are different class of variables, either it's numeric variable or character variables. And we also learn how to inspect the variables and the workspace. Besides that, we also learned the numbers representation, and there are some special numbers in the R environment, which is kind of unique compared to other languages. So we also learned the operators, like the actions that we can perform on the variables. So there are several, like arithmetic. You can do some scientific calculation using R. You can also do some relational operators, try to get a true or false value. And based on the true or false, you can actually run some logical operations like and, or not, those. And lastly, we also mentioned this operator's precedence. It's kind of useful when you want to write a very clean code. And an important part we learn about is the R objects. There are several objects, and those can be quite useful. Basically in R, when we program, we will need some kind of data containers to store our data. So basically we talk about the vector matrix. They hold the same identical data type. If you have a different data type, you can try the data frame if it's tabular data. And you can also use a more generic form, the list. So here I show the different types using different color. And the right part is how you can define or create a new vector, new matrix, new R objects. So for each of the R objects, we also learn some functions that can either create or indexing that you retrieve certain part of data. And because you can access a particular data in your whole data set, you can actually do some update. For example, just try to assign a new value to that particular positions. And lastly, we learn how to merge for example, you have two vectors, how can you merge them into just one final vector? And we also learn this programming basics. I would like to say this are actually the building blocks. If you want to write a very complicated program to finish a specific functionality. So basically you are going to need the if-else flow, the loops, for loop, while loop, and also the repeat. So besides these loops, we also learned how the apply family. So basically, apply family is usually preferred over the for loop or while loop because they offer a much cleaner way to do the operations. And sometimes they are much faster than just writing a for loop. So if you have the choice, I would suggest go for apply first. If the apply is not enough, then try other loops. So we also learn the functions, like there are already some provided function, the built-in function, specifically designed for different types of variables, for the class variable, for the statistical purpose, or simply for the mathematical purpose. And we can also define our own functions. So function, you can just think it's like a box, black box, take some input and give you the output. You can consider a lot of things to be functions. They are the set of actions that can be performed on the data. So lastly, we learn the packages, how to install them, load them. In the last part of yesterday's workshop, we learned the data wrangling part, or specifically for the file input output. Try to load a file from like TXT or some other intermediate file into the R environment, store them in a data frame, or just store them in the vector list. So basically, this is how we can import data into the R computing environment. And based on this, this already have existing objects in the computing environment. Specifically, we talk about several things focus on the data frame, like how to manipulate the observations, which is the rows, and how to manipulate the variables, which is the columns. So we talk about those functions. And if you are not familiar with them, go back to the slides. And I think the slides have some nice pictures showing what each of the functions is doing. So for today's topic, we are going to finish the data wrangling part. Specifically, I think this is kind of useful when you are transform your data into some better purpose. So the very first thing we're going to learn is the reshape function. So if you still if you have the experience of taking a picture, you probably realize there are some different modes of pictures, like a horizontal, or which is a landscape, landscape version, and also the vertical, which is a portrait version. So basically, those are you can think that those are two ways of representing particular data. And in the data frame, we also have the same thing that we want to, sometimes we want to convert a wider format of data into a long format of data. So this is we can finish this called the pivot longer. So consider right now here each of the ID, like each row is an individual, is a person, and each of the column is the, for example, the time. So you measure your week every day or every month. So you can consider this is a longitudinal data, it's a time course data. But sometimes you want to, so in this wide format, the focus is the person, right? Like every observation, every row is a person's data. But sometimes you want to really focus on the observation itself. For example, in the other format, you can consider each of the row is just your weight at that given point. So your focus is just the observation point, time point. So this is a long format. So how to use this function is that the first argument is always a data frame, and the second argument is the columns you are going to convert to transform. And later you can input two values. One is the names two. So basically just put a new column name. And here is the K. So meaning we want to convert the column names into this K column, okay? And the next one is the values two. So basically it's another string, a new column. So here you will have the value at the new column. And there is also another way to going back, like transforming from the known format to the wider format. So similarly, it's the usage is very similar to the previous one. It's simply just you put the names from or values from, just give it give it the K from the names from and the val to the values from. So basically you can convert the longer format to the wider format. So this transformation is pretty useful sometimes, especially when you are dealing with a longitudinal data set. And for data visualization, many times we would like to have this known format. If you are plotting, for example, you want to plot the data into different panels. Each panel has, for example, panel A only contains the X, and the panel B only contains Y. So basically you want to split the data to present them into different panels. And then this known format is usually what you want to have. So here is like a small animation, a small cartoon that's showing you how this transformation is done. So basically you are just trying to put try to put each of the observation into several longer rows, and each of them have the K corresponding to the original columns. And so beyond the reshape function, we also sometimes want to do some grouping. So this is useful when you have some kind of group of data. So still we can take the previous example, like your data set contains male and female. So if you are curious about within the male population, what kind of weight, average weight we have, and within the female population, what kind of weight they have. So basically you can use the group by function. So if you don't know this group by yesterday, you probably will go for the subset, right? You subset the data set into a smaller data set and then calculate the mean there. But with today's lecture, you can actually use the group by. The first argument is the data frame, and the second argument will be the name of the variables that tries to do this grouping. So just as a very straightforward illustration here, is that we try to put the same value. Like for example, this is a discrete value. It has 3 different values here, and so basically you summarize the data set, data frame into 3 pieces of data set, and within each of them, the value is the same. So this is we call the group variable. So with this group by variable, usually follow up is that sometimes we want to do some summarization after you finish the grouping. So you can following when you already have this group, the data set, you can summarize them. For example, you summarize it by mean, by calculating the average, or sometimes you want to summarize it by, for example, how many observations there. So you can use the counts, just a 1n to do the counting within each group. So I think later in the practice section, we are going to try each of them and see what the results look like. But I think the idea is pretty straightforward, right? It's something we really need. Usually in your data cleansing or data manipulation part, you want to do some kind of grouping and summarize. So group by will convert the original data frame into a grouped data frame. And if you want to convert it back, you can use the ungroup the function. So basically, it will just do the reverse thing, try to recover from the group data set to your original format. So the last part about the functionalities is how can we chain, like how we combine all the functionalities together to form a like a whole pipeline. So I think all the functions we talked about before, if you just trying to write everything, so yeah, maybe just take a look at this picture. So you can consider your data is the current, the flow, and each of the rabbit here is a function. So basically, you will see a lot of the functions will work together from one to another. So you can actually consider, okay, is there a way that we can like try to chain them together instead of writing a lot of assignments. So basically, for example, here in the left panel, probably it's the go-to format. Like when we don't know the pipe, we probably will write the data processing like this. Like for each of the line of code, you are try to calculate something, assign to a variable, and then for the second one, you compute it with a function, and then again assign to a variable. So basically, this is clean, and it is clean. And the second one that we are trying to nest the data in some way. Like we first compute the, let me see. Well, it's kind of hard to see, but basically what it tries to do is that we first do a group by, and then we summarize, we get a new data frame, and then based on this new data frame, we input as the first argument to filter. We do some filtering, and then we do some mutate. So basically, it will try to do some hierarchical processing. And the last one is actually we're using this pipe idea that it consists of like a 2% symbol with a greater than symbol with in between. So basically, it will what it does is trying to, okay, when you have the diamonds, you will feed in to group by, and this group by has some argument. After finishing this step, you feed into the next step. So it still have the same kind of structure as the first one, but it's kind of more clear, I would say. Like it's like has a kind of a flow direction from the beginning to the end, and you don't have those. You don't have to type in those variables again and again. So here is a small question: like, do you see like which one do you think is the most elegant? First one or that definitely not second one, right? Second one is too ugly. Which one do you think is best? First one or third one? Any idea? Like if you vote for the first one, raise up your hand. And you for the third one, raise up your hand. Okay, we have an agreement here. Okay, cool. So the good thing about the third one is that just consider like when you have when you need to write a lot of processing, the first one, whenever there is something change about the variable names. For example, you have a new data set, you probably need to change everything, like dimensions 2, and then you name it with the color depth 2. So you need to change a lot of things. But for this one, you actually just change the names in the beginning, color depth 2, dimensions 2, and just copy paste the rest. Because the rest has nothing to do with the variable names you input. It only has something to do with the function itself and the argument themselves. So basically, this is much more cleaner way to maintain your code. And when you need to run it to other data set, you just copy paste. You don't need to change anything. So basically, this pipe symbol will work by taking the object from the left-hand side. For example, here, this is the diamonds left-hand side, and use it as the first argument to the function on the right-hand side. So if you have a function that takes two arguments, x and y, you can actually just write it as x with pipe and with fy. So I think I can give you 1 minute to try on this small test, like how to rewrite this function using pipe. So I can show how to rewrite this part. So actually the answer is here, that you can consider, okay, we are going to compute fxy first, and then fxy I can actually be computed by using this x pipe to fy. So after that, we are going to pipe the results. Like this part is the first argument, right? So basically we just need to pipe the whole thing to gz. So still remember that the pipe works by taking the argument on the left-hand side as the first argument on the right-hand side. So this is a very simple way to write, like to transform the nested function, just using this the pipe flow. So next we are going to do some practice with the data wrangling. So I guess you guys can try to copy and paste this line of code to your RStudio terminal. So if you already have that folder here, just try to delete it first. Otherwise, you will Otherwise, you will have some issue with git clone. And check, okay, the folder is removed, and then git clone again. So you will see we downloaded the instructor file again. So you can open the folder, go to the D3 file. And if you have any problem with the git clone folder, like a command line, you can just go to the web browser, try to just put this as a website and then download it from there. Okay. So here is the materials for our data wrangling practice. I don't think we do it yesterday, so we are going to work on it a little bit. So again, like the very first thing is try to load the package, the tidyverse package. So it contains basically everything we will need in this workshop. It contains the dplyr and also contains the ggplot. So basically those packages is nested in this tidyverse. So you can run it first. And after that, you could try to read in the data, but try to remember that if you just run this line, it works right now because kind of like in the same folder. Sometimes if you like try to read a file, but this file is not within the same folder, you want to really specify the absolute path to that file. Otherwise, you will get some issues saying the file doesn't exist or something, not found or something. So basically, the read-in data, we use the read table, input the file name first, and then specify what's the separator for this file. So it's a CSV file, meaning this is a comma separated. So we can just use a comma as a separator. And for the file, we actually can just take a look at what does it look like from the command line. So basically for the first line, we see it's a sample ID, age, female. So this one is a header line, and the following part is a data part. So you can specify the header to be true. So after that, you can just inspect whether the data is ready. And because we have a different variable type across the columns, so you can actually see this is exact the definition of a data frame, that we have a string here, we have a numerical value here. Right, so if you hover your mouse into the columns, it actually will show what type of data in these columns has. For example, column 2 is a numeric, and the column 1 is a character. So basically, this is a data frame. And if you want to write the intermediate data to a file, you can use the save RDS. So remember, just try to save the data frame and specify a file name that ends with .rds. So after you run that, you will see there is a new file created in the folder. And if you want to, again, like when you finish or other work, and then you want to load this file again into data frame, you can just read RDS, just specify the path and the file name to the read RDS function. So after you do that, you will see another variable for the TCGA sample 2. So basically, about the TCGA sample 1 and TCGA sample 2, they are the same thing here. All right, so this is about the file IO. So you can also use the write the table, or use some other functions to read and write the file, like exchange data from your R computing environment and the file itself. But I think most of the times, those are just enough for your reading and writing. And many of the other functions, they are pretty similar. But sometimes if you want to read and write an Excel table, like ends with XL, SX. So if you want to read or write those, you probably cannot use the read table function, but there are also some other functions you can use. Try to Google it and then copy paste the code template. So for the first thing about the data wrangling basics, we are going to just use the built-in data from the tidyverse, which is the MPG data set. So when you run it, you will see the MPG. It has many columns, still a data frame. And here I listed the meaning of each columns. So basically, this is a few economy data from a period of time for some model of cars. And here is the meaning of the variables. And I guess we don't really need to know the detail, like what's the meaning of them. We just care about the computation. We don't care about the interpretation here. So before we work on the data frame itself, I still want to take some time to talk about the variables. So as you know, like first day we talk about variables, we have the numerical value. They can be the character, which is a discrete type of values. And we can define for the string vector, we can define the factors. Just try to run it, and you will see Y2. It's a factor level. It's a factor, and the Y1 and the Y2, they can be different. The levels is different. This is simply because if we don't specify the levels, the default is using the alphabetical levels. Like for example, the L, I think the H is before L, and then you will see the levels is arranged in the alphabetical order. And if you don't want to have the default order, you want to specify your own order, you can use the levels argument. And another part about the data frame is that we can create new data frames as we want, just using the data frame function, specify the variable and specify the corresponding values. And for each of the variables, it must be within the same type. So either be word numeric or be the word characters. And for the manipulate the observations, the very first thing we want to do is to subset our data based on certain conditions. We call it as a filtering. And for example, here we can filter MPG based on whether the variable model equals A4 or not. So if you run it, you will see the first part, the first one, the model will be A4. So basically what it does, it tries to extract a subset of data whose model is for the A4, okay? And you can also specify other conditions together. You want to, subset the rows whose model is A4 and the CYL is 4. So basically in the second part, you will see all the observations satisfy the filtering condition. The first one, because we only specify the first one, like A4. So we can see the CYL can be 4, 6, any other numbers. So this compound condition is just collected by the AND operator. So to interpret is that model equals A4. This will give you a true or false vector, and the CYL equals 4 is also another true or false vector, and you perform a AND operation. So it will actually do some element-wise true or false. So only after you run this, it will still give you a vector of true or false, but it's like a combination of these two conditions. So I hope that is clear. So the next thing, sometimes we want to do the ordering of the data frame. For example, if we want to order the whole data frame based on a variable and from the smallest to the largest in the ascending order. So you can use the range function to do that. And if you want to do it with a decreasing order, like from the largest to the smallest, you simply specify the variable, just put another function with it, put another function into the variable, like decreasing. So after you run it, you will see that the results, for example, for the first one, the results is ordered in the smallest, like a highway from 12, 14, 15, all the way to the 44, etc. So basically it's increasing. And similarly, the decreasing will just have the opposite, like from the biggest to the smallest. And a good thing about the range is that you can, after you ordering, you can use the head function to take the first several elements. So this is sometimes useful. For example, you have a gene expression data, and then each of the genes, you have a p-value. So you want to find the most significant 10 genes. So this is actually, you can use the range and also the head function to do that. And here is like when you have multiple data sets, several data frames, you want to bind them together, you can use a bind function. So here I just used, for example, here we created 2 new data frames that we do a subset, try to find the manufacturer. Dataset manufacturer is Audi, and then another dataset manufacturer is Ford. So after we do the subsetting, we want to combine them together. So this is how you can do it. The bind those, put the 2 data frame together here. So after running that, you will see the results bind those, and some of the manufactured Ford and some of the manufactured Audi. So basically it will only contain these 2 manufacturers. So another way, another way to do this to achieve the same result is you do the filtering MPG, and the manufacturer belongs to a vector, and this vector contains Audi and Ford. So basically this is another way to achieve the same results. So I guess I can give you guys maybe 3 minutes to finish this 3 exercise. So for the first exercise, we want to extract the observations whose CTY value is among the top 10. So I guess it's a very deep, straightforward way. So again, like we already know how to use the pipe function, right? So we can try to first arrange, right? So arrange is trying to sort our data frame in some way. So we can, using this data frame, pipe into the arrange function. So the variable we work with is the CTY, and we want to have it as among the top 10. So basically we can consider try to order it from the largest to the smallest. So using a DESC CT, let's just try to see what does the results look like. CTY, okay. So you can consider try to like find the tens. So again, like here we can see that like if it's a top 10, it's around like a 25, right? So what you can do is to do another filter. So this filter, what we want is a CTY greater than 25, greater or equal than 25. All right. So this will give you observations whose CTY value is at least 25, which is the top 10, where the top 10 values is. So I think this exercise kind of simple. So right now we only use the arrange function and also the filter function. We can finish it. And then for the second one, we want to extract observations whose manufacture is either order or fold. So as we said before, we can use the filter function. And then we want to have a manufacturer, right? That is either this one or two. So basically we can use the belong operator, trying to check whether the manufacturer is either order or fold. So this one, we just define a vector that contains these two type of manufacturers. So this one we can check, okay, the results is order, and maybe other rows have the fold ones. So this is the first thing that we can do the filtering first. And then we want to filter by CTY greater than 18. So we can do another filter, CTY greater than 18. But again, like you can also put this CTY to the previous filter, just put a and symbol, CTY greater than 80. But here, just to make it clear, I separate them into two steps. All right. And after doing that, you can arrange the resulting data frame by CTY in descending order. So this one is what we did in the first exercise. Just using the descending order functionality, CTY. And this one will give you the final results. So pretty simple after you know how to use the pipe, right? Otherwise, you are going to do a lot of self-setting and assignment. But here we have the pipe. You can consider, okay, we are just throwing the data first. Each step is this little rabbit perform some functionality, and then transform to the next rabbit, perform another functionality. So this is really convenient to use. I really like this pipe idea because I cannot find a good replacement in Python. So this is the reason why I usually use R to do data cleansing. So this is the second exercise. For the third exercise, let's just try how to try to see what's in the DF and DF2. So basically, you can see that we share one column X, but the second column is not. It's not the same. Like the name is not the same. So when you try to run the bind rows, xdf and df2, what you will get is that it kind of like try to align the data frame in some way. If it's not present in another data frame, you will get the NA value. So NA means, okay, it's not present in this data set, in this second data set, so it's missing. So this binder loss can actually do some checking for you. All right, so this is about the manipulated observations. So I think the filter and the range, those are pretty useful when you in your daily life, in your own work. So we move on to the manipulate the variables. Specifically, sometimes we want to do some kind of subsetting again, but it's not subsetting the rows. Subsetting the rows, we use filter, but subsetting the columns, we usually use this select. So here I want to mention a specific type of writing here. So basically here you can see that in front of the select function, I put the package's name with the double column here. So basically this will be useful, like some of the packages, they define the same function name. For example, in dplyr, we have the select function, and in another package, we also have the select function. So writing in this way will specifically designate that we are talking about the select function within the dplyr package. So this will not call another select function from another package, just using the dplyr. So I would suggest that when you are trying to use some functionality that is whose name is very generic, then you can consider try to write in this way. So if you want to see, okay, what else functions have the select, what else package has the select function, you can try to check. Or maybe double select. Let me see. I missed zero. Yeah, so basically, if you have other packages installed, probably you will see some kind of naming conflicts, like the select functionality is defined in both of the packages. Here, because I think my environment is kind of clean, I only have the dplyr tidyverse select. But if you install others, you will see some function that has the same name. Again, like this is just a small trick that you can use to avoid the confusions. And for the select function, again, like the first argument is always a data frame, and the subsequent is the number of the variables you want to keep within this new data set. For example, if you run it, you will see that the first variable, the first data frame we get contains the model, the manufacturer model year, and the displacement. And the second one, you will see we have the highway and the city. So it's just like we are subsetting the columns. And sometimes we want to create new columns. We can use the mutate function. This is pretty useful. For example, you have a data set measurement about the height and weight of a person. So you can actually calculate the body mass index based on those two variables, right? So this is, I guess it's quite useful in some way. Instead of just using Excel and then program there, you can just use the mutate function to do that. So here, I just calculate the ratio between the highway and the city. So you can see here we have, we can just verify, like, for example, 29 divided by 18. So it's 1.61, so it's the same. So the ratio is just trying to get a ratio between these two, and mutate is used to create this create this new column. So in yesterday's lecture, we also talked about how to merge the data frame by columns. So I guess maybe you guys can take 1 minute to try on the left join, for join, right join, and see how the results look like. So I guess I can also do a small demo about how to do the merge by columns. So basically, this will involve the join functionality we talk about. We can just first try to check what is in the df3 and the df4. So sometimes you can also try to check the columns just using the column names mpg df3 and mpg df4. You will see that there are 3 columns overlap together. And if you use, for example, the inner join, you will just put the 2 data frame as the 2 argument. And then there is another argument you need to specify is the by. So again, like you don't need to type in everything. You just, when you finish something, you want some prompt, press the tab key. So the tab key will give you some kind of suggestions what you want to specify later. So after that, you can just choose, okay, I want to specify the by, meaning, so using which columns, like an anchor, and then you are going to join the data frame. So basically, because we have the three columns that are shared together, so we just put them into a vector. Okay, manufacture, I just copy paste. Okay. And remember they are separated by the column. So after that, maybe I just write a temp1 as the final results, assign the results to the temp1 to hold the data. So I think manufacture model here. All right, yeah, I guess there are like some kind of many-to-many mappings here. So basically, when you have the by when you have these variables, but these variables might be duplicated in some way. For example, we can check this manufacturer model year, but they probably corresponding other observations. They could have the same value for these 3 variables, and those when you are combining them, so basically you don't really have a really unique identifier for this observation. So this is why we have a warning here. So in your daily usage, I guess usually you want to have like a very unique identifier. For example, the sample ID. So each of the observations is a sample, and it has a unique ID. Then you want to use that column as a by column. All right. So this is like intended to give you some kind of hint about some. If you don't have a unique ID, then you probably are going to see these warning messages. So others are pretty similar, like for join, left join, right join. The syntax is pretty similar. It's just like we are joining the data frame in 2 different ways, or in several different ways. So still remember that we have the pipe operator we can use. So instead of just writing it with in this form, you can actually do, for example, you put the mpg df3 outside and use a pipe function, and then just remove the first argument. So this is also giving you the same results. Simply put the first argument to the left-hand side with the pipe, and then the rest follows. So this one will give you the exact same results. Yeah, it's pretty much the same thing. So the next part about the data wrangling is a reshape from the wide format to the non format. So as we mentioned before, that we can use a pivot longer or pivot wider to do this transformation between two formats. So here we can check, okay, then PGDM4, DF4, it's a wide format right now because we have the two columns at the just have the two columns here as a side by side. And then if we want to pivot into a non format, we can specify the argument, the data frame as the first argument, and then specify these two columns. It's that we want to transform, and we want to transform the names to a new column called type, and transform the values to a new column for the mile per gallon. So if you run it, and you will see from the new created data frame, you will see the highway and the city, those two columns will be converted to type. It contains either highway or city. Mile gallon contains its value. So we can still like correspondingly check these two. For example, for the first, if it's a highway, the value is 29. So you can still see if it's a highway, the value is 29, right? So it's just like two different formats. One is in the non format, and one is in the wide format. And you can clearly see that the non format has more observations than the wide format. So it's doubled. So the exercise, maybe I can just do it here. Should be pretty easy. Just using the pivot wider, like names from the type. So basically, the type contains the variable names, and the values from the mile per gallon. And we can assign it to like temp2 data frame. So again, we probably have some kind of a duplicate issue, but again, like at least the highway and the city is transformed from the previous non format to the wide format. But again, like this is not a perfect example about how to use it more faithfully. But I just want to show like how to convert them back. And again, if you are doing this converting, it's usually recommended to have a unique identifier. So I guess probably you can do it using true. Yeah, you can try to specify some of the ID columns to the unique identifier. But here we don't specify anything here. So I guess okay. Now the last part I think is just the group and the summarize. Again, as we said before, we can just run it from here. The group is trying to have several groups variables, and then combine split the data into small pieces, and each of the pieces has the same value as the year and the manufacturer here. So we can run it. So after that, we see for example, after we run the group by and then summarize each of the group with the mean value, highway mean and highways and the city mean. So this is the results we can get. It's simply just try to first group your data frame based on these two variables. Like these two variables will be used as a grouping criterion, and within the group, we are going to compute the mean for each of the variables. So this will be the final results you will get. And the last part is about the type. So we already seen that before, so I'm not going to talk too much detail about that. So I guess we can take a 10-minute break from here. When we come back, we will talk about the data realization part. So let's everything about the practice on the data wrangling. So I hope I gave some examples that how useful this function can be, and basically you can use it in your own research, I guess. So instead of just using Excel, you have another option using the R to do those operations. And the good thing is that the R code, once you wrote, it's there and you can use it just with a small modification. You can reduce a lot of like repetitive work you have done before. So the next section about the workshop is data visualization. So I want to emphasize that this is kind of an important part in the research, but usually we don't get really don't get enough training about the data visualization. So here I want to show some facts on how our brain reacts to the visuals. So this is a natural reason why data visualization is important is that from the most of the information we receive every day, more than 80% of them will be just visual properties. And this is also explains like we are born to see something, but we are not born to read, right? The reading is learned in our like learning, but we like naturally can just see something. And so this is a really important part about why data visualization matters so much. It's just like how we are dealing with the world just in this way. Like our maybe 50% or more, our neurons are designed to see something, right? So you probably have already heard about this saying before that a picture maybe worth 1,000 words. So this is said by a famous computer scientist who invented the algorithm about finding the shortest path within a network. So to give you a small example about the saying that I once asked ChatGPT, okay, please list the planets diameters in our solar system. So basically it did a great job, right? Like list a very organized, listed the diameters in a very organized way. So I can see them one by one. I can maybe spend 0.5 seconds just trying to identify which one is the largest one, which one is the smallest one. But this is not intuitive enough. If we have some kind of figures like this, we don't really need to go through line by lines to see, okay, which one is the biggest one, which one is the smallest one. So we just look at the picture and say, oh, okay, I got one, the Jupiter one is the biggest one, it's the largest one. And the Mercury is the smallest one. So we can just directly get the information very fast, very rapidly, right? So this is a very good example about why a picture can be worth more than 1,000 pictures, 1,000 words. But the visualization can be also imprecise. So especially for the specific example I gave here, actually they have some issue. So anyone can point out the issue? Any issue you have found? So the pictures is good, but they usually lose some kind of precision. So if you still want to report some results with a very high accuracy, the numbers is usually needed. So here in this picture, the imprecise part is the distance between planets. So they cannot be so close, right? They are side by side. So this is impossible in reality. So usually like we always dealing with this pros and cons. Something is good in some way, but you need to sacrifice the accuracy a little bit. But there are also some other ways. For example, you can add necessary annotations to the figure saying, okay, the distance is not so accurate, etc., to avoid the misconception. And that is for our like learning part, and in the science part, the role and the load of data visualization is usually expressed in this form. That as a scientist, we use the data visualization to explore the data. We want to identify whether two variables, the follow certain pattern, like we have a very good correlation, or we show some kind of weird functionality. So basically, we can use the data visualization to explore. And after we explore and finish all the experiments, finish all the analysis, we want to communicate our results to the potential reader, either it's an editor, reviewer, or just the general public. So basically, we want to explain our results using data visualization. So this in both of these two ways, data visualization plays an important part. And then in specific data analysis projects, you probably see such kind of trend is like a repetitive thing, it's an iterative thing. You use the data visualization to form some kind of hypothesis, and then you build models, and then you adjust your models, and later you get another data visualization. So it's an iterative thing. And luckily, we have this ggplot2 to help us with data visualization in a pretty convenient way. So here I want to showcase some example I take from a Nature paper last year. So basically, you can clearly see maybe just from the figure itself, you can tell, okay, these figures are made by ggplot2. So it's like probably not Python or some other Excel languages, just using ggplot2 to create them. So basically, you can see when we are trying to compare the group difference, we can use the box plot, wrangling plot, and if we want to show some distribution about one variable, we can use the histogram. And you can visualize the composition using this bar plot, and you show some kind of a tendency using the line plot. And you can use the scatter plot to show the relationship between one variable to another variable, and using the heat map to show the whole landscape, whole profile of your data. So basically, those are all accomplishable in ggplot2. And we are not going to learn everything. Learn everything is too challenging here, like within a short time. But we are going to learn some basic things behind. So the idea behind ggplot2 as visualization, just to take the scatter plot as an example, is that we have this data frame. After we finish all the data wrangling, we get a really nice layout of the data frame. Like we have the rows, columns in a very pretty good shape. And we want to get a figure like this. So what we're really doing here is that we try to map the variables to the visual properties here. For example, we define what variable is the x-axis, what variable is the y-axis, and what variable is used to color the dots. So basically, it's just try to define some kind of mapping, like what is mapped to x, what is mapped to y, and etc. So to do this, we can use the ggplot function. So this is still a function, and it takes the data frame as the first argument, and then it has a certain of mapping that we describe, like a map one variable to x, another variable to color. So we define this AE as aesthetic mapping to do that. And then the following part will be other arguments. If you really care about what is other argument, you can put a question mark on the ggplot in the RStudio interface and see what other options it provides. So this will only give you the initial plot object, but sometimes you want to do some modification, like you want to plot the curve, or you want to plot the scattered points, like each of the dot is a point. Then you usually want to add a plus sign and add an additional layers to the plot. So what about the layers? Like we will explain it later, but let's just try to showcase the component. One is the data, and one is the mapping, and the other ones are the layers that describe how we want to present the data. So let's just showcase a really simple example. We still use the MPG dataset, specify it to be the first argument, and then specify what is the x, what is y within the AES function. Okay, so after we do that, we get this figure. Right now it only has a, okay, we know what is X, what is Y, but we don't add any layers to the plot. So it doesn't show any data, right? It only shows X and Y axis. So if we want to show the data, we need to add some kind of layer. So here it's just a geometry point. We want to present the data at the point. Each of the observation is just presented as a dot here. And if you want to color it, we can again just specify another aesthetic mapping within the layer geometry point. For example, we use the drive as a color, just specify AES color to be drive. And then we can add another layer that is try to run a linear regression, fit a linear curve. So basically we see, okay, the message we get is that the displacement and highway, they are in opposite correlation with each other. If the highway goes up, and then probably the displacement should go down, etc. And later, if you want to further polish the figure, you can try to adjust the theme or just add some titles, subtitles to your plot. And here I show this is that we can add one component after another in an iterative way. So this is a good thing, because sometimes we don't really know, okay, what's the results look like. So we want to make a small adjustment first and then add up to reach to the final result. So basically you can use a plus sign to do this step by step iteratively. So this is pretty flexible you can do. And usually I think the order probably sometimes it matter, but usually it's fine. So about the different component, so I want to mention the layer, the grammar of graphics. So as you see in the previous example, we added the plot. We created the plot layer by layer. So basically, it kind of has the layer, the grammar of graphics. This was the first proposed by this very intelligent guy, Leonard, in his book, the grammar of graphics. So basically, in this book, he defines what layer the grammar should look like. It has a data first, and then you define the aesthetic mapping. Okay, what is X, what is Y, and then you define the geometries to represent the data, to render the figures for you, and you have this succeed. Like when you have multiple groups, you want to split them into different panels, and you have the statistical transformation, coordinates, and the themes. So basically, the ggplot is designed based on this layered grammars. And for each of them, we are going to learn some of them, but not everything. So in this workshop, in this intro workshop, we are going to learn about everything except the coordinate and the statistics, because these are kind of advanced topic. I don't want to overwhelm you guys too much. So we are going to learn some basics about each of the component later. So the first thing about the aesthetics. So again, like aesthetics is simply trying to map the visual properties to some of your variables. So the visual properties can be the position, for example, X, Y axis, the shape, like if you are plotting the scatter plot, it can be a circle, it can be a triangle, the shape of the dot, and the size of the dot, and also, for example, color. If you are doing with a line plot, you have the line wise, whether under the line type, which is a dashed line or solid line, etc. So those are all the aesthetic properties. And when you define the aesthetic mappings for ggplot, you can use this AES function. So basically just put the name and the value pairs. So for example, name is a aesthetic property, and the value is your variable. So this one, here I listed the options for aesthetic properties. And basically, when you are plotting, you just need to change, okay, what you want to use for X, what you want to use for Y. So for each of the properties, for example, for the line type and for the shape, they have certain numbers, labels there. For example, if you want to use a circle line, you can specify the shape to be 0, to be 1, or something else. And if you are curious about the options you have, simply copy this line of code into your RStudio IDE, and it will show, okay, for each of the aesthetic properties, what type of options you have. And another thing I want to mention about is aesthetic mapping. So mapping is that you map a variable to the properties, but the variable can take several values. So basically, this is an ideal way. For example, if you want to use a variable to color your plot, but there is also another thing called the aesthetic settings. Settings is more like, okay, you don't want to do that kind of grouping things. You just want to specify the same color for all of your data points. So the whole difference about the mapping and the setting is that whether you are going to put the value name pairs within the AES function or outside the AES function. So if it's outside the function, then it's a setting. It will try to give you the same blue color for all of your dots. But if you put into the setting mapping, later in the ggplot tutorial, we are going to see these two lines actually have different results. We will later see. So besides, for here, we see that we use a geometry point to render our data. So this is related to the geometry, like how you are going to present your data. So here is a list of geometry objects, selected list because they have contains many more. We are not going to learn every single one, and those are like the most widely used. So geometry blank, it will display nothing, and if you want to display a segment, a line that has a starting point and ending point, with like a finite line, you can use the geometry segment. And if you want to have like a line with the infinite length, you can use the AB line, geometry AB line. This will specify the slope of the line and the intercept of line. So like with these two values, you will get like a whole line ranging from negative infinity to positive infinity. So besides that, you can also use some kind of other objects here, like the geometry path, which will collect the observations in the order of the data, so which will be sometimes useful if you are doing some advanced statistical computing, for example, the MCMC, if you heard about that, like Monte Carlo Markov chain. So basically, it will try to show how the variables change in your iterations, like you are having like a contour plot or something. And if you just want to show the observations according to the location on the x-axis, you can use a geometry line. Later we will say in the tutorial what's the difference between geometry path and what's the difference between geometry path and the geometry line. So if you want to draw a rectangular in your plot, you can use the geom-rect. This will draw a rectangular. And if you are trying to display a line with a certain region, you can use the geometry ribbon. So this one will usually be useful when you are trying to plot both the mean and the standard deviation for each of your data. So this kind of plot the uncertainty of your data in some way. So about the detailed usage, just put a question mark and with the name of the function, and you will see the whole documentation there. Because the the space is limited. I cannot put everything, but those are like most commonly used ones. And we can also classify the geometry objects based on the number of variables. For example, if you only want to show one variables, then probably the most reasonable way to do is that you are going to plot a histogram or bar plot in some way. For example, if it's a discrete value, it's a bar plot. For the values, it might be duplicated. You want to count the values and see how they distribute. And if it's a continuous variable, you can use the histogram or use a density plot to show the distribution. Because right now you only have one variable, so the only thing you can show is the distribution, right? If you have two variables, then based on the variable types, whether it's a continuous or discrete. So if they are both continuous, then the natural way to think about is the scatter plot, right? The x-axis, y-axis, they are continuous. So the natural way is scatter plot. And then if you want to load the regression, like how these two variables related, then you can using the geometry smooth, try to fit some kind of functionality, fit a linear regression, etc. You can use the geometry smooth. And the geometry rug trying to show the marginal density for each of the variables. And if it's one continuous, one discrete, so this is maybe usually the case in biology setting, then you have two groups. So the group is a discrete variable, but the weight of your mice or something, this is a continuous variable. So you can consider to represent them using the box plot, wrangling plot. Probably you have already seen those plots before. So basically this is can be done just using ggplot with the geometry box plot, wrangling plot function. And sometimes you probably have a lot of plots with the same value. So when you plot them on the figure, you will see they overlap exactly with each other. So if you don't want to have those overlap, you can use the geometry theta to avoid the overlapping. So again, like there are so many ways to present your data and so many ways to visualize the data. So I guess the most important thing you should consider is that you should choose an appropriate geometry based on what you want to say about the plot, what message you want to convey. So for example, if you want to show the distribution, go for the histogram, go for the density. If you want to show the difference between groups, go for the box plot and also wrangling plot in some way. And if you want to show the relationship between two continuous variables, go for the scatter plot. So basically, what type of geometry you should choose really depends on the goal of your figures. Okay. So besides the geometry and the aesthetic mappings, another important thing is the scales. So here is more like, okay, when you look at the plot without any notations there, you don't really see anything, right? So for example, when you try to measure something, you need to have a ruler. And if you want to see the pH value of a liquid, then you have like a reference. So the scales is more showing like the law of reference. So the syntax of a scale is that you put a scale with your aesthetic property and with the type. The type can be continuous, discrete. Aesthetic is the ones we mentioned before, either position, color, fill, size, shape, etc., etc. So just take an example that in the aesthetic mapping, we define, okay, the color attribute is mapped to the variable in the data, like a DRV variable. But we didn't specify, okay, what the four should like what color should this group of four use. So right now it's like a default color set, but sometimes, for example, this group of four, you want to use a different color. You want to, for example, use a blue color, and then another one use a black color, etc. So those kind of color value and the variable value mapping it's defined using the scale syntax. So before we talk about color, I want to talk about the position first, because I think this is the most, I think it's like a first thing to do when you are trying to make a plot. So you can adjust the plot. So just using the scale with the axis can be either X or Y, and put a type here. So the type can be discrete value or continuous value. So in this syntax, you can specify the arguments like name, the limits, briefs, and labels. So the name is simply just like what title you should use for the x-axis and the y-axis. So this is usually the case when you have a variable name. If you don't specify them, the x-axis name will, like the label showing here, will be just a variable name. Sometimes it's not informative at all, right? So you want to give it a different name, so you can use a name argument. And if you want to plot the figure as at a certain range, you can use the limits of 1 and 7 or some value you define. So right now, I think it's a 40 to 100 limits, right? So this will just adjust what part of the scale you want to display. And the breaks actually just defines what values should we have the break here. Like here, I think it's 40, 50, 60. So those are the breaks. You can specify them, control them using the breaks variable. The labels here, it's just saying, okay, what text you should put on the breaks. So sometimes I think it's useful. For example, maybe in reality, you have 1,000, 2,000, 3,000 as the breaks, but you don't want to have a lot of zeros in your label. So you probably can put a 1K, 2K, 3K just as the abbreviation. So these are the 4 commonly used arguments. For the color part, I think it's similar way as a position that you put a scale and the aesthetic mapping. The aesthetic can be either either file or color, and the type is continuous or discrete or manual, etc. So we are going to go for file as an example. For example, here, if you want to produce 2 colors, like a sequential color from transition from one color to another, from low to high. So this is usually useful. For example, you have a one directional change from the low to high or from 0 to 1, etc. So you can specify the low color to be one color, low to be one color, and the high to be another color. All right. So this gradient will produce a 2-color gradient, like from low to high. The monotony increasing. And if you want to have a diverging colors series, you can using the gradient 2. So this will give you 3-color gradient with the midpoint specified. So this one we will have to specify, okay, what's the low, what's the mid, and what's the high. This is particularly useful when you are displaying the direction and also the strength. So for example, just consider the bar is the correlation bar from -1 to 0 to 1. So basically you have three different three different points here. And the more closer to 1 or -1, we know the correlation is high, right? Either positive or negative. And the closer to 0 means the correlation is weak. And so in that sense, we want to use the 3-color bar because we want to first display the correlation strength, either high or low. But on the other hand, we want to show the direction of the correlation, either positive or negative. So you want to really have something diverging, like from the middle point, you are approaching to 2 extremes with 2 different colors. So basically, in the end, you are going to end up with 3 colors. So here we also have the midpoint. Usually, if you don't specify them, I think it will be 0. But yeah, you can change. Okay, where is the middle point? Where is the why the color should happen. So besides this two color scheme, you also have a gradient N to produce an N color gradient, but this is less commonly used because I think when you have too many colors, it's very hard to distinguish, or the plots get too busy and you don't get any information there. You don't get any clear message. So probably you should avoid using the gradient N in many ways. And if you have for the gradient, it's usually for the continuous value. And if you have a discrete value, for example, you have different groups, and you want to assign different group with a different color, so you can use the scale field brewer, just place the name of the planet. So basically, it will give you some fancy color. So for example, for the second one, I guess that's probably most people would like. It's like the green is not purely green. It kind of has some gray value there, and also it gives you some kind of a sense of classy, right? It's not like a very pure green, pure red, pure blue, but it's something mixture with the color, and the gray color give you a sense of yeah, I don't know, like a feeling of classy, but it's more related to art. So if you want to use other color sets, just put the names to replace the set 1, set 2. All right. And sometimes you probably want to specify your own color. Like you don't want to use the default color. You don't want to use the set color. You can specify your own color to the several groups. Like for example, group 1 will be green. Group 2 will be black. So simply use the scale field manual. The manual means you are manually supply a set of colors. Just specify this string vector to the values. Additionally, you can use a named vector. So this one will try to assign the gray to the group D. Assign gray black to the group of B. So basically, I think the named vector will avoid such kind of a mismatch issue. Probably in reality, you should always go for the named vector. All right, so that is about the scale. And the next thing is about the facet. So facet, I think, is important when you have a very huge data set. When you plot everything on the plot, probably it's too crowded, too busy. And you really probably just want to plot the data for different panel, different subset. So the facet is used to do that. So here there are 3 different types of facet. One is facet null, which means, okay, it's a single plot. We don't do any subsetting data. We just plot everything. So this is by default the behavior of ggplot2. You don't really need to specify it. It will automatically do it. And sometimes we have the facet wrap. So basically it will just consider that you have 3 groups. So you are going to end up with 3 panels. And the wrap is just trying to wrap the 1D ribbon into a 2D plot panel. So for example, if you specify the n column to be 2, you will have like 2 columns on the top, and then 1 panel on the bottom. So the facet grid is that we want to produce a 2D grid of panels, define the variables to form the rows and the columns. So later we will see an example about this. But for example, but let's talk about facet wrap first. So basically here, I just want to use this figure to show what does the facet wrap do. This is like one of your data set. So when you want to present the groups, probably you will see, okay, they are, you only can tell, okay, they are different in different locations, but probably it's not so clear in some way. But sometimes you want to like split the whole data into different panels. So for example, for the panel for Africa, it will plot give 1 plot. For another group, you will give another plot. So you can use a facet wrap to do that. just put a tilde and your variable name to do that. So the following part will be other parameters you can specify, like you can specify the number of columns to split. So right now, for example, we split the plot into n column of 2. Or alternatively, you can specify, okay, how many of the rows you want to split. So here you have another variable parameter, the direction. So this will just try to decide how you are going to wrap the whole plot into this 2-dimensional. So if you can either use the H for horizontal and using the V for vertical. So this one is just like you are making a lot of plots and then you want to arrange them into a 2-dimensional way. Like you have 2 rows, 2 columns here. So the facade grid is doing something similar, but you actually have 2 variables to control the facading. So again, like for example, you have one variable denoting it's group 4, group 6, group 8, and another variable you are denoting it to be either 4 or F. So basically, the facade grid is trying to create a grid of panels. Like for example, here in this part, it's all the data point that has one variable to be 4, and another variable which also have the value of 4. So basically, it's trying to split the data based on the grids, and within each of the grid, within each of the panel, it will try to make this plot. So you can specify it in this B tilde A, denoting these 2 variables you are going to use. If you replace any of them with a dot, so basically it will means, okay, just omit that dimension. For example, B tilde dot. So just spread the values on the rows. So similarly, if you put the first one as dot, then it's just split by the columns. So one thing I want to mention about is that if you have different panels, like a different plot in different panels, then you can actually control whether these panels share the same limits of X and Y axis. So basically, you can use a scale parameter to control the panel scales. If it's fixed, that means, okay, all the panels share the same X and Y ranges. If you want to have more flexibility, you can either specify free X, try to allow the X can be different across panels, or free Y, allow Y to be different across panels. Or if you want to be more flexible, you can just simply specify free, like allow X and Y to be different across panels. So those are about the panel of the facade. And the next part is about the plot customization. So I think this is quite important in any realization that when you have when you have a lot of customization of like based on your own desire, your expression power is greater. So I think it's quite important, and also why ggplot2 is so popular, because they offer a lot of customizations. But this whole topic is quite deep. I'm not going to go too much details about that. So I'm just listing the most commonly used ones. So one of the important things about figure is that we want to customize the title, the axis, subtitle tag, etc. So instead of just using like you generate the plot in the PDF version, and then you use Adobe Illustrator to edit those things, or simply use the PowerPoint to edit those things, you can actually just build in the plot that you want. So just simply use the labs, this functionality, specify the title, subtitle. So if you don't specify anything, it will be just empty. Okay, if you want to specify something, just put a title, subtitle. The caption is here. and the tag, like usually each of the plot, they have a tag A and B and C and D. So basically you can also put the tag over there. So there is another way to do that using the GG title to specify the main title of the figure and also the subtitle of the figure. But this is how you can add the small notations to the figures.
It's like standard specific notation in the overall figure.
Right.
Might change depending on the journal you're publishing to.
Yeah, so there are also some other customization options you can use to change the specific position you want to put. For example, the title right now, the default option is just put on the top left part. Sometimes you want to put it in the center, right? And also the front. Right now it's just a plain. You want to make it a bold font or use a different font family. So those are all customizable. But we are not going to learn it today because there's a whole another workshop, the advanced ggplot realization plot topic. We talk about that. So if you are interested about that, in the later slides, I put a link of the previous workshop. But right now, just using the default. Okay. So another thing about the customization is about the themes. So again, like previously, you see those gray background and the white gray line. So it's a kind of default theme about ggplot. You can actually change it to something else. For example, here I listed 9 of the themes. They have a whole set of themes. For example, I think usually my favorite is the theme. BW stands for the black and white, so it contains like a much cleaner background, and also with the reference line like horizontal and the vertical gray lines. So I think this is my favorite, but you can also use others. So if you want to use it, just simply put a plus sign under the same BW. Or if you want to change it for all the plots, you can use the theme set function to do that. So I think these are the built-in things. And if you really want to change a specific part about the plot, so you can use the same function. And again, that one is in the advanced ggplot 2 workshop. We are not going to talk about it today. So after you finishing all the plot generation, making the plots, the rest of the thing you want to do is, okay, I want to have a file. So it's like either in the PNG format or the PDF format. So luckily in the RStudio, you can just click your mouse to export the figures as an image or as a PDF to do that. So if you want to do it with a code, it's also doable. But before that, I want to talk about the figure format. I think it's kind of useful. So basically, the figure format can be categorized into two groups, 2 types. One is the vector graphics. So basically, it describes a plot as a set of operations. So this is really what we want, because when you define them as operations, then no matter how you zoom in, you always get the same resolution of figures as much clear as possible. So this will mean you won't lose any kind of resolutions when you change the size of the figure. And the raster figures is the opposite. It's actually just store the plot as an array of pixels. It's just like when we are taking a picture using our phone through our lens, you see those like pictures, right? And each of them will be pixel. And when you zoom in, and then choose the very high resolution, and then you probably see this blur, like blur grids. So basically, because the image is stored in the discretized form, each of the pixels, they have a value. And when your resolution is super high, you probably will not see the edges. It's not a circle anymore. It's just like a kind of different boxes. So ideally, like when you are saving plots, you need the vectorized graphics is preferred, unless there is a strong reason you want to use the raster graphics. So for example, some paper channels, they probably don't want the vectorized graphics. So this is the reason one. And another reason is that maybe when you have a lot of components in your figure, for example, the scatter plot with millions of dots in the figure, then the vectorized graphics will take a long time to generate, and also the file size, maybe a figure can be several hundred megabytes. Then in that sense, the vector graphics is not desirable, because when you are having a very huge size of the figure, opening it will be problematic. It takes very long time to open it. Okay, so in those two sense, you probably go for the raster graphics. Otherwise, you always choose the vectorized graphics. So the vector graphics is usually the PDF version or SVG version, and the raster graphics is the PNG or JPG version. So these are the most commonly used format. So if you want to save the plots to a file, you can use a PDF or PNG, the standardized R approach to save. So simply just put PDF. For example, if you want to save into the vectorized format, put a PDF function, put your output file name, and put the dimension of your figure, for example, the width and height. And then you are going to generate the figure after this line. After that, you call this device off. So after you call this one, it will try to generate the figure and save to the PDF. So this one is it's like the ending of the whole chunk, whole saving chunk. So if you want to save into the raster figure, simply replace the PDF with PNG. And there are also some other parameters you can use. But we're not going to details about that. So another easy way to save a file, to save the plot to the file, is using the ggSave in the ggplot2 functionality. So basically, it will just try to you can just using one single line to save the plot to a file. And if you don't specify the plot, it will automatically save the last plot you generate to the file. So I think it's kind of useful sometimes. And another good thing about ggSave is that it will automatically choose the file format based on your file name. For example, if you put the file name to be the .pdf, it will automatically choose, okay, we are saving the vectorized format for you. If you put a PNG, then it will automatically save it as a raster file format. So here are also some other parameters you can use. I'm not going to too much details here, but if you are saving it into a PNG, you can specify this parameter. Basically, it controls the resolution of the plot for you. All right, I think that's everything we have for the realization part. I want to do a small summary about ggplot2. So first, we have the layer, the component from the data to a certain mapping to geometries. So this is basically the structure, whole structure of ggplot2. And based on the structure, you can easily see the corresponding relationship between the structure and also the code template, like how if you are going to call ggplot2, basically you can see these two, the left hand picture and the right hand code, they have the similarities. So basically you are going to input the data, input the aesthetic mapping and geometry functionalities. Also, you are following with some coordinates function, facet function, and same function, etc. So the top panel is the general syntax, and the later bottom panel is the specific example. You can see like the whole syntax looks similar. And in the ggplot2 visualization part, we also talk about like the several components. You can consider the whole data plot generation process as an iterative way. For example, you have the data and you kind of design a base plot, and then you specify what type of the graph is. And then you are adding some labels to the plot. Lastly, you are going to change the themes of the plot. So this is can be done separately and step by step. So this will be quite flexible. You don't really need to write everything in just one whole line, but you can plot something and you don't feel happy about it. So you add another component and add another modification to it, and then update the plots. So in the next quarter, I actually teach another workshop called the Advanced ggplot2, Advanced Data Visualization with ggplot2. It contains more details. So if you go to the website I provided here, if you are feel interested about the details, you can check the slides I provided. Yeah, the file probably will be a little big, so take a little while to load. Basically, you will find the more detailed version of data visualization in R. It contains every component, I guess, here. And more details. If you want to master this ggplot, you can check the resources. All right, I think we can take a 10-minute break from here, and then when we come back, we will work with the RStudio materials. So we have already covered all the slides about ggplot2. The next part is about doing some practice. Before we do the practice, I want to make a small announcement that we are going to have a homework assignment for this workshop, which will be released on the weekend. And considering you guys might have some midterm in week 5, so we are going to give you 3 weeks to finish. And the homework assignment will be pretty similar to the code we covered in the workshop. So because this is a workshop, it's not like a formal, like a formal class that spans from the week 1 to week 10. So we are not going to give you a very hard time. The point here is just trying to make you learn something from the workshop. So like giving you a hard time, giving you a B or something is not our aim. Okay, just try to like follow these things, learn something, and that's the whole point of this workshop. All right, so let's dive into the ggplot2 practice. As we see here, still in the day 3 materials. For the first part, it's about build the plot layer by layer, which is the example we show in the slides. So here is a specific code that we can use. So when you are trying to create a ggplot, just simply use the function ggplot with the data frame specified and with the aesthetic mapping specified. So this will give you the very basic plot. It contains nothing, but just the X and the Y axis as you specified. So if you want to add on something, for example, you want to represent the data using the point geometry with the colors, then you simply use the plus sign and specify the geom point with the aesthetic mapping that the drive is mapped to the color property. So this one you will get the second plot. And for the following part, is that you add another layer for the geom smooth with a linear model. So this will give you a smooth like a regression line to the plot. And the next part is you can try to adjust the theme and add some title or subtitle to the plot. So in the final one, this will be what you get. So here I want to point out that each of them is like a subsequent order. Like you can see from the base, we plus another term for the second plot, plus the additional term in the third plot, and plus the final plot. So basically, you are actually making the plot step by step and doing it in an iterative way. So this is a good point about ggplot. They offer such kind of flexibility for us. And another thing I want to mention is the aesthetic mappings. As we said, there are many aesthetic properties like the position, X and Y, and the color. So here it's just to try to, okay, you can try it out and see when you specify the color to be one value. And if you specify the size, it looks like this. And if you specify the alpha, which means the transparency of your point, then it looks like this. And if you specify the shape, which means like whether you are going to represent it using a triangle or a square or a dot or a circle. So basically, you can specify the shape. So another point we mentioned in the workshop is about aesthetic mapping and setting. So these are simply can be differentiated whether you want to include the name and the value pair inside AES or outside AES. So if it is outside, then it is a setting. So it will use the design color. If it's inside the AES mapping, this name and value pair is actually trying to treat the part you provide as a variable, and then it will use its default color. So if you run it, you will see a difference. For example, if it's a setting, then it will just use a color as you designed. If you use it within the aesthetic mapping, so basically the blue is treated as a variable, and actually the color you get is actually the red. So this is nothing special, but it's just how the aesthetic mapping treat your expression. So again, like when you have just one value in a variable, I guess probably you just need to specify the aesthetic setting. If you have multiple levels in that variable, you can use the mapping. This is a difference. And I think I can give 2 minutes to maybe finish this exercise. Also, the exercise says we need to build a plot that contains the following elements with those settings. So remember that we can always consider to use a pipe functionality. Like you can use MPG and then ggplot. So basically here, you don't need to specify the data frame anymore because it will automatically use the left-hand side as the first argument. And then you want to specify X as the highway. So just put everything within the AES function and use the Y CT as the Y-axis. So next part is to set up a point shape. We can use the geometry point. The geometry will be the point. And then we want to set the color and the shape according to CYL. So again, it's a aesthetic mapping. So we can try to specify shape as CYL and the color to be CYL. Okay. And then after that, we want to set the theme as BW. Okay. And then we want to add the title and the subtitle, just using the names. In the slides, we mentioned that with the title, scatter plot, and the subtitle. It's the city versus highway. Okay, so basically this should do everything as described. But let's give it a try. So basically we see an error saying, okay, the shape must be some discrete value instead of some continuous value, right? So here is a exact message. So how do you solve the problem? So let's first check in MPG. So let's see what is the CYL. It's a numerical value. So numerical, we know it's a continuous value. Although the value it takes is 468, seems to be discrete, but the data type they have is numeric. So the point to solve this problem is just trying to change this CYL to some discrete value in the when we assign to shape. So here we can use, like when we talk about the discrete value, we see it's a string. You can put a string like using the as character to do that. But I think a more appropriate way is just trying to give it as a factor, like it's an integer, but with levels. So if we do that and run it, so we don't have the problem anymore, and then the results, the figure shows like this, like we have the CYL just as a color, continuous color, but we have the shape to be the factor. Okay, like the 4, 5, 6, 8 structure, like with different shapes. So this is how we can solve this exercise. And the following part, I guess I can move a little quicker. Say, for example, the geometry. What we did here is just try to test what each of the geometry look like. So for example, if we run it from the reverse in between. So if we use the first one, which is the which is just based on the geometry blank. So blank doesn't do anything. So what you will get is still this blank figure. It doesn't even have the aesthetic mapping. It doesn't have the X and Y axis specified. And if you want to add some lines, so you can use the V line and the H line. So which means the vertical line when you specify the X-intercept, and the horizontal line when you specify the Y-intercept. So besides that, you can also add some other lines. For example, the linear diagonal line using the AB line functionality, specify the slope to be 1, intercept to be 0. And you can also specify some other properties like the color of the line and the line type. So in the slides, we also mentioned the geometry line and the geometry path. So here you can see the clear difference between them. So the geometry path is trying to first order the data points according to the x-axis, and then collect each of the data points using a line. So you see some kind of tendency, but they have the up and downs. But for the geometry paths, it's more like you are collecting one observation to another observation. So it's more like a zigzag shape. And I just said, if you are working with the advanced statistics, you are plotting some random work like a Brownian stochastic process, then you probably will see like they are showing some kind of this kind of massive pattern. And if you want to plot a region, for example, a rectangular region, you can specify the geometry rectangle, specify the 4 different values, which is like the 4 corners. What's the minimum value X, maximum value X, minimum value of y and the maximum value of y, and you can specify the fill, which means what color to fill in the rectangular, and the color which means the borderlines color. So this is how you can do it. So and another thing is about the other geometries. For example, if you have a single value, you want to show the distribution, you can use the geometry bar. So it will actually count the number of appearance in your data frame, plot a bar plot, and then you can use the histogram to show the, if it's a continuous value, to show the histogram. Additionally, you can use the density plot, which is just a smoothed version of a histogram, but it eventually will just show the distribution. So I guess we can skip this exercise for now. Just move on to the next part. If we have two variables, so the natural idea is try to plot the two variables. If they are both continuous, then plot them as a scatter plot. And if you want to add additional lines, like a regression line, you can use the GeoMod smooth. Specify the method to be LM, stands for linear model. So this will give you the linear regression. And if you have the one discrete value and one continuous value, you can go for the box plot or violin plot, or sometimes even the geometry point, like a scatter plot. But for the box plot, it will show like for each of the group, for each of the group, the discrete value group, what's the data distribution look like within the group. So here it's like the median value. So you can clearly see some group is higher than the other groups. So basically you can tell some kind of difference between groups. And the violin plot is more like a detailed version of a box plot. Instead of just showing the median range, it will actually show the real distribution. So each of the curve, like if it's flat, that means this area has a high density. Otherwise, this means this area has no density. So it's a violin plot, like more details. And here, the following two lines is what I want to show, that when you have a lot of values that probably they overlap each other, and you don't really see how many dots within this plot, because some of the dots may be 2 dots or 3 dots. You cannot really see that. So you can use the geometry data to do some kind of dataing, like it will kind of spread the data point a little bit. So you can see, okay, although it doesn't show that many in this plot, but actually they have a lot of values. They have a lot of points. And besides that, one thing I want to mention, which is kind of important, is a heat map. You can use a geom tile. So basically this will, this one is a little bit more advanced. It actually involves 3 variables. The x variable, y variable denotes the x and y position. And you have also another variable denoting the color of that region. So the region we created using the geom tile. So if you run it, you will see that, okay, for each of the x and y, we have a set of variable denoting the color. This will give us the heat map shape. So this is just a very simple example. You can actually do the heat map in a more fancy way, more advanced way using the functions I listed here. But here I'm just showing, okay, what data it look like and what does the heat map look like. So the next part is about the, let me see, it's a scale. So right now, I think maybe we are running out of time. So although this is the exercise, but basically you can use the scale color menu, try to assign the red, blue, and green to the as the as a value in that scale color menu function. So you will end up with the red, blue, and green. And the next part is about the facet, that we simply can try different options, facet null, facet wrap, and the facet wrap with scales to be specified, like X can be different across the panels. And the last one is the facet grid using two variables, year and class, and then try to plot the whole figure. So basically you can see the difference, and it's essentially just splitting the original data set into different subsets and make a plot over there. And if you want to change the title, you can use the maps. So this is also something we've already talked about. And if you want to change the themes, here is just like a small example using original ones. It's a gray background, and if you use a BW black and white, much cleaner, etc. So you can try it with your own plots later. So if you want to save the plots to the file, you can use the ggSave to do that. And otherwise, you can also use the PDF or PNG function as we specified in the slides. So the next part is something I feel I need to mention a little bit, but you probably will learn more about these details in the modern stats workshop. So specifically, R is a scientific computing software. So the most charming point is that you can use some functionality to do statistical test or building a linear model or something. For example, if you want to run a t-test, you simply just put two different vectors as the x and y here. So basically here, what I do is that, okay, I extract the highway from the observations whose drive is F, and then compare to that of whose drive is 4, and then see whether there is a difference between the highway values between these two groups, okay? So if we run it, we see, okay, this is a 2-sample t-test, and then we have a very small p-value showing, okay, there is exactly strong evidence showing these two groups have difference. And if you want to calculate the correlation between two variables, you can use the core function. And if you want to get the p-value, you can use the core test. So what you did is just try to specify the vectors as the x and y in the function. So again, the p-value is high, 0.95, and within our expectation, the p-value was very small. And sometimes you want to run a linear model, like you're trying to use one variable to predict another variable. So you can use the OM function, which is a linear model. Specify this is the left-hand side, it's the response, it's a y. And the right-hand side is the x, it's the predictor, okay? And then you specify the data frame. So after you do that, you will see, okay, when we fit the linear model, what is the coefficient? Like intercept is this value, and the beta, like the slope, is this value. And you can also get a kind of p-value, saying how strong the relationship is between these two. All right, I think that's everything about the tutorial. And then let's go back to the slides a little bit. Let me see how to zoom in a little bit. Yeah, okay, I think just using this mode. So basically, I provided some quick resources for you guys to check out. So you don't really need to remember everything. If you need to see the, let me see how to zoom in a little bit. Presentation mode. All right, we have everything now. So basically it's a cheat sheet. So if you click it, you will see basically what we taught in the workshop can be summarized in just two sheets, two letters. So if you don't forget, if you don't remember anything, you forget about the usage of a specific function, about the how to write a function, how to write the loop or something. So you can always go to the base R. So this is for the very basic cheat sheet. And if you are more curious about the data wrangling part, this is a cheat sheet you are going to use. For example, it contains how to do the reshaping of the data, how to do the subsetting and the observations, the rows, and subset the variables. So besides what we talked in the workshop, it contains many more other functions you can check about. So I like the part that they also provide some kind of illustrations. For example, for the combine, the left join, right join. So basically you can see, okay, when we combine these two, if we run left join, what's the output node should look like? So it's really useful. You don't again, you don't really need to remember anything. Just look at these shapes. And this is another ggplot2 visualization, showing what figures you will have when you run this particular line. So I still think it's very informative and provide a lot of information. And lastly, there is art tutorial. If you feel okay, you need to refresh the whole topics, you can check each of them. And the good thing is that we provide some kind of portal. You can try it yourself. For example, when you run it, click it, it will pop up a window with the command line and with a certain output panel. So you can also try it. So again, like practice makes perfect. So it's a 3-day workshop. I'm not expecting you guys to master everything. So just if you want to really learn, master this skill, try to practice. At the very beginning, as we said, the R's learning curve is kind of steep. You probably feel kind of uncomfortable because many of them are not so familiar with you guys. But after years experience, you probably can do it more efficiently. But there is always some unexpected things. There was something more to learn. So after years and years experience, you probably still need some issue, but you will be more confident to address them. So besides that, you can also get help from either the community, for example, ggplot2, but they also have some other forum there, like the dplyr, etc. You can check the R graph gallery to get some ggplot2 template. You can check the Google Stack Overflow. They have a bunch of people asking questions and a lot of good answers there. Lastly, you can always go for ChatGPT. Like whenever you met some issues, copy paste your code and copy paste the error message. Ask a ChatGPT to solve it for you. For example, the one thing I did is that I can upload a figure to ChatGPT and ask it to generate the code. And then after I have the code, I would do my own modification, try to adjust the colors, adjust the code structures, and then finally I can repeat or replicate the original figure. So this is a very good way to do. You don't need to write everything from scratch. Okay, they provide a template, and then you just modify it. So it's still like you are standing on the shoulder of the giants. So it will save you some time and effort. So after, I think that's everything about our workshop, and I'm not sure if I have the time, but I would like to suggest you guys, like you in the GitHub repository, you will see 2048 script. So basically, it's a small game. I'm not sure how many of you guys have played it, but everything we learned in this workshop can be actually used to write our own 2048 game. So for example, the code logic should like this. You initialize a 4x4 matrix with 2 random cells with value 2, and then you are going to have the program wait for the user input. For example, it's like a W as A and D, denoting you want to swipe up, swipe down, left and right. So based on the signals, it will do some kind of reactions. For example, it will merge the adjacent same numbers. And then if it's an exit signal, it will terminate the program. If it's other signal, it simply ignores it. So after that, you can use it to use a ggplot to visualize it. And then you check if the program should terminate 2048 is obtained, or there is no other actions you can put. So basically, you can see this is a for loop. There is a while loop going on. There is a if-else condition going on behind the program. There is like a variable and also the matrix. So everything we learned in the workshop can be actually combined together to form a very complicated example here. So if you are curious about the code, you can check here. And I think that's it. This is a cool example. You guys can try and see if you can understand the code in your way. Okay, I think let's what? No. This is not the homework. It's far beyond the homework. But I just think it's something useful. You can try. It's fun. And with that, I think that's all of us materials. And thank you guys for joining the workshop. And I hope you guys have fun with art.